All right, everybody, we are live. Thank you for joining us. Today I'm going to be going through a sneak peek of DoneJS. This is a presentation that I gave on Tuesday to JavaScriptChicago. We're pretty excited about the launch, and with that I will share my screen and go over the presentation. Let me see if I can. All right. Hey, David, can you see the slide? David or Adam?
Looks great.
Okay. So this presentation is going to be an introduction to DoneJS. I'll be going over why you should use DoneJS and give an example of using it to build a very simple chat application. DoneJS is the successor to JavaScriptMVC, and as a result of 2 very hard years of work, the road from JavaScriptMVC to DoneJS has been long and difficult and is a great story in its own right, but for now I'm going to stay focused on the wonder and features that are in DoneJS. So DoneJS's motto is your app done. Our goal is to make DoneJS the easiest way to create a high-performance, maintainable, and highly usable web applications. Really, what we want to do is, people have solved checkers mathematically. We want to do that with JavaScript development. So all of the big, hard, nasty problems that you really need to do to execute on a sophisticated JavaScript application, we want DoneJS to help you with that as much as possible, hence the name DoneJS. So with that, we have just a bunch of maintainability features. It supports very tight unit and functional test support. Our guides talk through how easy and show how easy it is to do continuous integration deployment. You can use ES6 modules or AMD modules, CommonJS modules. This is just a quick highlights of some of the maintainability features. You can use NPM packages and install them how you would with a Node project. We use the modlet file organization pattern, which means that every folder has its own test files, documentation, styles, if it's a widget that has styles, test page, and more. We use CanJS that supports custom HTML elements, and it supports an MVVM architecture, and we have fun things like hot module replacement. DoneJS also comes with a really nice guide. It's actually probably about to have 2 guides. A place my order example guide where you build a pretty lightweight restaurant ordering application, but it's got a few complex use cases that you have to build, and it's comprehensive in terms of the scope of everything that we do to make it work. The other guide is the chat guide application, which I'll be going through at the end of this. But what sets DoneJS apart from its competitors is its performance story. DoneJS is designed to make it easy to squeeze out every last bit of performance JavaScript juju that the browser can offer us. But to see why its performance is so beneficial and what some of these things mean, you need to compare it to how a traditional single-page application is built. So first, let's look at the experience.
1 second. I don't know if you're supposed to ask questions, but I was wondering what you consider competitors, since you mentioned it, because I'm not aware of anyone that does a full stack solution really for everything that you need to build an app. Do you have a specific?
Ember does do that.
True. Yeah. Okay.
And there are so nothing packages it up the same way that we do, but Ember is trying to also be kind of a comprehensive framework of frameworks.
But by the way, just a point, like that word, also competitor, like it did raise flags in my head and made me start thinking about comparable things immediately. Just just thought it'd be a speaking note to share with you.
Yeah, that's the idea, as I want people to be thinking of those things. Because I do want people to think about what it takes to, like what it takes to build an application, and if our competitors, including Angular and React and Ember, are, you know, all that matters at the end of the day is that you can build a successful application, and who's going to help you get there the easiest. And I would say that DoneJS will, but where it's going to help you the most is its performance story. Because, yeah, with our competitors like React and Angular, especially React does have server-side rendering, does talk a lot about performance, but the things that actually matter for performance in terms of the user's experience tend to be things that those frameworks don't help you with, where we really help you with a lot of that, which is like loading scripts and things like that. That really matters. Server-side rendering matters too, but we'll talk about that. So first, let's look at how traditionally you're building a single-page application with either React or Angular or just CanJS by itself. You are loading a simple HTML page. Typically, the server with a single-page application just responds with very simple HTML that loads the CSS, maybe puts a loading splash spinner on the screen, and a script tag that loads the production JavaScript code. So here's where I'd ask, like, you know, how many people build applications like this? When I did this for JavaScript.Chicago, almost everybody raised their hand that this is how they build things, right? The server is not responding with HTML. It's simply just responding with enough HTML to bootstrap JavaScript. So let's take a look at what it takes for the user to go to a traditionally built single-page application site and get back a fully rendered interactive page. And what we'll see is that there's often a lot of unnecessary steps and a slow user experience, an unnecessary slow user experience involved with a traditional single-page application. So let's break down all the different steps. So when a user first goes to the page of a standard single-page application, as we already said, the HTML response, the server sends back an HTML response that looks something like this. So the user will wait for this to download, which honestly does happen pretty quick. But while the production JS is loading, they will see a spinner, right? They won't see their content. They won't be able to reason about what's happened. If you're looking at Gmail, we've all seen that little loading bar. We can't see what emails we've got at this point and try to pick our favorite. Instead, we're just looking at a spinner until JavaScript is fully loaded. Now, to load the JavaScript in CSS, most applications, at least when they're beginning to be written, download a lot more JavaScript than is needed, and the downloading of that JavaScript in CSS is a lot slower than is necessary. It can be optimized. The reason why more JavaScript is downloaded than is necessary is because people tend to just bundle up their entire application, every single different page is JavaScript, into one big JavaScript file. And same with the CSS. And the reason why it's slower is because typically people will host their static files from the same server that's serving up the HTML page. As we'll see in a second, you can distribute your static files across a content delivery network. So if my server is running in San Francisco, I don't need to go back to San Francisco to get my JavaScript. Instead, I can load it from a local cache in Chicago. That's why here we have those little squiggly lines and a big box to show you're downloading more and slower than is necessary with a traditional timeline. So then once JavaScript has finally loaded, then JavaScript typically needs to request data to actually show in the page. So JavaScript will kick off, make an AJAX request, and then finally, once the server again has responded with HTML or with AJAX data, JavaScript puts that in the page. So you get this kind of 4 different steps until the user actually sees what's happening and can interact with the page. Now let's compare this to what happens with a DoneJS server-side rendered application. First thing is the user goes to the page, and DoneJS will render the application server-side, and also while rendering it server-side, spot or is able to see what data the JavaScript client on the server is requesting. It sees what data the client needs and packages that up in the page and sends that whole thing back as the response, initial response to the HTTP request. So at this point, the user is seeing exactly what they're going to see when JavaScript has finished running in the traditional single-page timeline. And then the next thing that happens, so they see the content right away, but then with a DoneJS application, they will load just the JavaScript they need to power the page and just the CSS, and they will load it from a content delivery network, so JavaScript and CSS loads much faster. So the DoneJS timeline, if you look at it, it's the user sees what they, the fully rendered page and can start making decisions about the new content that you've shown them right away. And then typically, before they've even been able to think and act upon that data, they've downloaded the JavaScript and CSS necessary to run the page. So we're going to prepare hard data on this, but with my experience and kind of seeing these things in action, here's my approximate timeline for kind of how things would likely shake out differently in terms of the performance of a traditional app versus a DoneJS application. The traditional app would be most likely able to serve up just that dummy static HTML much faster. Not much faster, but reasonably faster than there's much more content that we have to send down as the HTML response and the data in a DoneJS application. Of course, you can cache this, so it doesn't have to be generated, the HTML result, the server-side rendering result, you can cache it, so it doesn't need to happen every single time a user comes to the page. But we're very fast at rendering it, but it still, of course, might be a little bit faster to get the HTML page out in a traditional application. However, this is all offset by everything that happens after that. So again, with a traditional, it's going to take a while to download your CSS and JavaScript, and then finally it's going to have to request actual data and put it in the page. Where a DoneJS application, the user sees the data right away and then downloads the JavaScript and CSS much faster. So I think that on average, you're probably looking at least like a half-second speed up especially to when a user can see their data, and probably maybe a couple hundred milliseconds, maybe faster. It depends how fast the CDN is to when the page is interactive. But we're going to get some hard data on this before we really present this to many other places. So, this was a slide I accidentally added when I was talking with James. So yeah, really what it comes down to is, what do you want your user to see? Do you want to see the data right away, or do you want to see a loading screen right away? Okay, so for the rest of this presentation, I'm going to be showing how to build a very simple chat application, DoneJS Chat. It has a little dummy tabs on the front page, and you can click the Start Chat, and it takes you to a chat window where you can enter your name and your message, and it shows up. So this chat is going to solve a lot of the most complex problems, performance issues. It's going to demonstrate that. So it's going to be real time. It's going to use caching techniques to store old chat messages in local storage so that it can display them immediately. It's going to be server-side rendered. It's going to be progressively loaded so it only loads exactly what is needed, and it's going to be deployed to a CDN. So we have these 7 steps. We're going to set up our DoneJS application. I'm going to add Bootstrap, and then just check out how awesome hot module swapping is with it. We'll add some simple routing to go from one page to the next page. Then I'll finish the behavior for the messages page, then hook the messages to a real-time connection. I'll finish the home page, and then I'll build the whole application and deploy it to a CDN. So step 1, setting up an application, I think is really easy with DoneJS. You just npm install DoneJS globally because we want to install the command lines that let us create an application. And I'll let this run. So that's step 1. Step 2 is it running? Sometimes I can't tell if the page is actually going or not. Okay, so step 2 is once you've installed the DoneJS command line tools. Oh, no, this is not. I skipped the slide because I didn't know it was playing. Okay, I think this is it. No, I think I went back to the same slide it was on. I need a marker on these if I'm going to do this right. Okay. Okay, it was this page. So once you've installed DoneJS, I'm going to create a chat folder and cd into that chat folder and run this DoneJS init command. DoneJS init is going to ask us some questions like what is our project and in what folder do we want most of our source code for the project. We will have it in the source folder. And just some other information to kind of fill out this application's package.json. And it's going to create a skeleton, a bunch of files to run a very, very small DoneJS application. And it's going to install all of DoneJS's dependencies, which is what you see here. Once that's done, the last step is just to run the DoneJS server. And you don't have to run the DoneJS development server. There's different kind of flavors of what you can run. The DoneJS develop server will do the server-side rendering and also set up steal so live reload works. But here, it started the server-side rendering page at localhost 8080, and if I go, I can see the dummy application that DoneJS init generated. So the next thing I want to do is add Bootstrap and check out hot module swapping of this dummy application. So let's see a little bit about what that generator produced. You can see here we have the chat folder with the source subfolder in it, a package.json, and some other files that we'll check out, at least build.js later. And what it generated that kicks off everything, this application's main module is this template right here called index.stash. This is the application that is server-side rendered and also rendered on the client. It's sent to the client and rendered there and kind of controls the behavior of our page. You can see here when I added live reload how it just immediately showed up in the browser on the right. I didn't have to hit refresh. This is hot module swapping. What that means is whenever I change a JavaScript file, the browser will detect it and automatically re-render itself. But it doesn't have to do a refresh. It only has to update the modules that actually changed. So now I want to add Bootstrap. So I'll npm install Bootstrap and make sure I save it to my package.json. And one of the cool things is how, because DoneJS is very HTML driven, right? That's the main page, looks like an HTML. You can actually import modules and CSS directly from your HTML. So here, this is kind of like HTML imports a little bit. Here, I'm going to import Bootstrap's less with this can import tag. And I'm also going to change the page HTML to actually make use of Bootstrap. And then when I hit save, you'll see that the right-hand side updates automatically with showing hello world but styled with Bootstrap. I think that's the end of this video. So the next video shows off shows off server-side rendering. So if I open up the developer tools here, and I'm going to refresh the page to show what the server responds with, which we can look in DevTools and see this localhost. This is the actual response of the page. You'll see that at the very end here we have h1 hello world. So the server is actually sending back that template rendered to us. Okay, the next thing I'm going to do is add routing between a home page and a messages page. Different pages in a CanJS application are often represented as custom elements. Custom elements are represented with components in CanJS. So here I'm going to generate a component that creates a custom chat home element. And I'm going to create it in a home component file. And these are ways of creating lightweight custom elements. So here you can see I'm declaring a can component. I'm using a custom element to define another custom element called chat home. It has its own styles. It has its own template that is rendered inside any chat home element. And it comes with a dummy view model, which we won't really use here. So here, I'm just going to create a, whenever we add a chat home element, I just want it to have an h1 inside of it that says DoneJS chat. Well, it's actually going to show the DoneJS logo, followed by the word chat, and then we're going to add a link to the messages page. So there's the DoneJS logo, there it says chat. We don't need this view model because our page doesn't actually use a view model. And then I'm just going to create a link, which I noticed that should be can href. I don't know if I go back and fix it. I must have at some point and not noticed. That should be can href page equals chat. But this creates basically what this creates is a link that when clicked on changes the state of the application, its page property to equal chat. So now I need to create the messages page, and I'm going to create a messages I'm still going to create a component, but at this time I'm going to create a component that's built with the modlet file organization structure, which means instead of one file that contains like every style, template, view model, everything, instead we're going to create a folder that contains each of those as individual files. And this is what we tend to do when we're building a big more complex behavior, we do it in a modelet. So you can see here is the messages folder with everything we want, but the template for the message custom element is this messages.stash, and here I'm just going to change it to add a link back to the home page. So again, this will change the page part of the application state, and it'll set it equal to home. And we'll see how to, using that, we can switch pages in a second. But one thing I want to do is make sure we have pretty routes. So I'm going to create a rule that says, instead of, say, making the URL look like page equals home, page equals chat, instead I just want /home/chat. So now I want to switch pages between the messages page, or the home page, and the messages page. Or the messages component. So what I'm going to do is, when the page property is chat, I want to actually dynamically load the messages component. I want to progressively load it, in case it hadn't been loaded already. And then while it's loading, I'm actually going to show a little loading text. So while this basically renders a promise in here. So while that promise for the messages code is loading, we'll show loading, and then once it's done, we'll actually show the chat messages custom element. And I'm going to do the same kind of thing for when we're on the home page. So if the page isn't chat while we're on the home page, at least for this application, so I'll load that home component, and instead write chat home. So here's how we can accomplish quite a lot in a very limited space. We can load our code, show that it's loading, and also put it in the page when it's ready. So now we can go back and forth between these two pages really easily. You can see the URL changing. Okay, so we have our two different pages. Now I'm going to finish the messages page so it actually includes, allows people to actually chat. So to actually work with real data, I need a model, and DoneJS comes with Can Connect, which has a SuperModel, which is a model that is able to use local storage. It's able to do real-time by default. To create a SuperModel, I can use the generator SuperModel generator, and then I provide the URL that I want our message model to connect to, and I give it the ID, the unique identifier that uniquely identifies each message. And if we look at what this generated, it generated inside the models folder a message module. And really what this is it's a can map that defines so when we're getting raw data from the server, we want to say, hey, it looks like a certain type. We want to make it so it's not just plain JavaScript data. We want it to be able to have methods and things like that. That's what this does. And it also creates a custom element that allows us to use our message model directly in the page. So what I'm going to do to show all my messages in the page is I'm going to import my message model and then use that custom element to load message data. Now, for people with, who have aversions to this, you don't have to be loading data in the template. We tend not to do that in big, sophisticated applications, but I think this shows how quickly you can bootstrap functionality in a DoneJS application. So here I'm using my message model to get list data, and I'm saying give me all messages, essentially. Those are the parameters passed to my message model. That class bit there is really just there for Bootstrap. You can ignore that. It's just so Bootstrap renders this as a container correctly. And the context, this subsection, what message model its insides are rendered with, is actually a promise. And we're just saying I could do the whole if pending, show loading, and then when it's done, go through each item. But instead, I'm just waiting until there is data, which is that value property. And once there are messages, for each one, I'm going to go through it and list each message's name and message property. So it's kind of weird that there's message.message. I think, David, we should change this to message.body or content, so it's a little less confusing. But all we're doing is loading data from the server here, looping through. And also, if there is no data, so that's why there's that else case, we're just going to write out no messages. So here you can see when I went to the page, we correctly loaded message data. Now, what I want to do is make it so we can create message data. So I'm going to create a little form-like section here of the page that allows me to enter in the user's name and their message. So that syntax will change with 2.3 to parentheses bracket value equals name. But this sets up two-way, that value equals name, that sets up a two-way binding, so that if the value of the input changes, it's going to update name, the name property of the view model. And I'm going to create another two-way binding on the message property of the view model. And when someone hits the enter key inside the message input element, we're going to call send on the view model. So the view model have a name property, a message property, and we need to create a send method that actually creates a message on the server. So to do things with the messages on the server, we need the message model, which I'll import from my models folder. And here I will create the send method. Now I'm going to do everything with ES6. So if it's a little bit confusing, you can use normal JavaScript, even though I'm not. So here I'm going to create a new message on the client using the message model. And I need to set its name property to the view model's name property. And that was two-way bound. And also the view model's message property that is two-way bound. And I will save this new message to the server so it gets created there. And then when the save is complete, I'm going to update the message property of the view model to be empty so that we remove the text that person has entered so they can just type in new text right away and create another new message. So with that, that's all it takes so that I can add a message. Now you'll notice there was no code for me to add the message that was created on the server to the list of messages, right? I never had to wait till that message was created and go to messages.list or something and push in that new message. How does this work? It works with set logic, which I'm not going to go into, but but just to say can connect is able to understand how you requested data and use that to infer what lists. So if you request a list of data, you pass it params, and using those parameters, we can determine which items belong in which lists. So if you create a new message, we know to add that to the list of all messages, because when you requested all messages, well, you probably want all messages. If that makes sense. But it's an awesome feature. Just know that it's there. With more time, we can talk about in other presentations. So the next thing I'm going to do is connect real-time services. To do this, I'm going to use Socket.io because our server hosts a Socket.io server. Start. There it is. So to use Socket.io, I need to npm install Socket.io. And in the future, this is going to look like npm install steal Socket.io, because there's some things that we have to configure that we'll see here that you won't have to in the future. So once I've installed Socket.io, I need to connect our connection to Socket.io, or actually tell, when Socket.io gets messages, we need to tell our connection that messages have been created, destroyed, or updated. So I'm going to import Socket.io into the model. And Socket.io we don't want running on the server. We only want it running on the client. So we need to do a little bit of, we're going to actually configure it so that there is no Socket.io on the server. And because of that, that actual I/O that we imported could be undefined when we're on the server. So we're going to add a little check to make sure that Socket.io actually exists. And if it exists, we'll put in the URL of our Socket.io connection, and then we're going to listen to messages events. So first I'm going to listen to a message is created, and when a message is created, I'm going to tell the message connection that an instance was created and pass it that raw data. And underneath the hood, setLogic will be determining which lists should have this new message added to it. Similarly, we're going to do the same thing when a message is updated or a message is removed. We're going to call these methods on our messages connection with that raw data that's changed, and let it really figure out how to update lists and update messages that are on the page for us. But what's awesome is that's all you need to do to kind of set up your real-time connection to a CAN connection. Now, I mentioned that we have to configure Socket.io not to run on the server, because you don't want your server kind of updating things when some other server changes your real-time server. There's really no need for that. So here, I'm configuring it so that Socket.io is empty, if not, there's no module there when you were on the server. So with all that, I can put in a name and a message, and have two browsers open. You'll see that the other browser responds to that message created event and inserts it into its list auto-magically. So the next step is to finish the home page. Here we're just going to add the tabs widget. And this is, again, just to show you how easy it is to install things and use them. So easy that I think, I think a lot of, my hope is that a lot of Bitovi's designers will be able to follow this process if they want to add widgets on their own. You just npm install your custom element, and then in a template, you import that module. So I'm going to import bit tabs. I'm going to import the unstyled version of it just because we're using Bootstrap and the default tab style conflicts with Bootstrap's. But then all I have to do is import the module, and then I can actually just use it as a custom element. Because, again, Bootstrap is a little weird, there's this extra tabs class which we will add to the UL that's internal to this bit tabs. So this is just, that tabs class is just there to make Bootstrap work. But I can create different panels, multiple panels for my inside my tabs. So I'll create one for CanJS and talk about the features what CanJS provides to DoneJS, which it provides the MV star parts, MVVM parts, and also has a control, even though it's not as heavily used anymore. And Steel.js provides a lot of the build infrastructure and a lot of other utilities like that. So, and the final thing is I need to update the styles because it doesn't come with any default styles. So I want to make sure it looks right. So I'm just making sure panels end up looking right. And with that, well, notice I just went back to the page and the server side with the hot module swapping just automatically updated and showed the tabs without me having to refresh the page again. And you can see our tabs works. So that's it. Just npm install your widgets, make sure you import them in your template, and you're off to the races with them. So the final step is we want to build and deploy this application to a CDN, Content Delivery Network. And a Content Delivery Network, keep on this, just in case anybody isn't familiar with what I mean by a Content Delivery Network or CDN, what that basically does is distribute static files across the world. So if I want to download something, I don't have to go to a single server, which might be in Hong Kong. Instead, I will probably go somewhere in Chicago, which is where I am, to download some content, which makes loading JavaScript much faster. But first, let's actually start with in development in the DoneJS application. Every single file is loaded independently. And currently, with even this very small app, there's 275 requests being made to load the application. Now, even in this app, it takes a little bit to reload the application. But fortunately, hot module swapping can dramatically reduce the amount of time we even have to hit refresh. But we definitely don't want in production 275 requests. So, I think it takes a little bit to get the action started here. Okay, so when we generated the application, it generated this build script. And I'm going to run it to package up our application into highly optimized bundles that can also be progressively loaded. So you can actually see it opened up 3 different main kind of pages. The main page, like the main module, the index.stash, and then it did it with the home component and the messages component. And then it built out a bunch of different bundles that when we run our application in production, and to run our application in production, I'm going to run node env equals production. This is just a handy way of setting an environment variable, and then I'm going to run the server-side rendering server. And when I reload my page now, we will get 9 requests. You can actually reduce it a little bit more. You can bundle Steel Production in with your other bundles, and you can also specify the total number of bundles any page should load. But I think the default is 3, which is typically optimal. So now we went from 275 requests to 9 requests, and it's also doing the progressive loading. You can see it's loading the DoneJS chat messages at the end. Actually, why? Well, that's actually something to look at. I'm not sure why it's... Oh, I know what that is. Actually, what it's doing is it's loading the index.js, which is the main application first right away, because that needs to load to determine what page we're on. Then it says, oh, we're on the home page, so load the home page, but it also is loading the code that's shared between the chat page, or the home page, and the messages page, I think. I'm not actually sure what that DoneJS message is. I'll have to check that out. So the next thing that I want to do is make this load on a CDN. So here we're going to use DivShot because it has a free account. And I've created an account on DivShot. And all I need to do is install the DivShot CLI. And then log into DivShot so that I can actually push from the command line. Kind of cool that it opens up a browser window when you type in from the command line. So once I've authenticated, I need to configure my deploy so it goes to, well, there's a few things I need to configure. I need to tell in production where the application thinks it's being hosted from. So it's being hosted from DivShot, and I also need to configure a DivShot config. This config is kind of heavy, but fortunately you can, for the most part, cut and paste it. And I'm giving the name of our DivShot server. That's really the important part here. And with that, I can run DoneJS deploy, and that will actually send all of our production JavaScript files to DivShot and CSS. And now if I restart the server, the production server, and reload, you'll see that we're loading everything from DivShot.io. And actually, I think, well, I don't think the load time should have gone down because we were loading locally to my computer, and there's no loading faster than that. But for users around the world, the load time would certainly go down. Okay, so what did we just accomplish? We just built an application that's in very little time. That's real time. I didn't actually show off the fall through local storage cache, but it is there where it's actually storing messages in local storage, so that if I come back to the page, it doesn't have to reload all of them, or it actually shows them right away and then makes a request in the background and then updates them behind the scenes. But it is server-side rendered, it is progressively loaded, and it is deployed to a CDN. But there's another really cool thing that I want to do, and I want to make this work on iOS, Android, and desktop applications. And it's something else that DoneJS can help with. So to make those other builds work, I need a little dummy HTML page because we're not going to be able to run the server-side rendering. So we do need, kind of one of those standard traditional single-page application HTML page that mostly is just enough HTML to bootstrap JavaScript loading. So I'm just going to make a little dummy HTML page that loads our main stash as app.html, and then I'm going to add a little extra build script that I've copied from the guide. And This uses the Steel Cordova plugin to build out an iOS build. If you've never heard of Cordova, Cordova lets you package up a JavaScript application into a native iOS application. Really, it just kind of runs a browser. But the experience it feels just like a native application. So I added that to my build script. Now I have to install a few things to make it so that I can actually run the simulator. And I have to install the Steel Cordova extension that lets you take what Steel's build artifact is and pass that to Cordova in the right way. So after installing those two dependencies, also you need to install Xcode, but I'm not showing that. But once all of those things are done, you just run node build Cordova, and this will actually kick off Steel's build and then pass the result to Cordova to be built to iOS. And takes a little bit. And here we can see the chat application running in the iOS simulator. And we can even see that our chat application can talk to the browser. Yay. Okay, so that's not all. That's not the only platform in the world that I want to build to. The next, I want to make my chat application run on the desktop, something like HipChat or Slack. Here, I'm configuring NWJS, which is kind of like Cordova but for desktop builds. I'm going to use the Steel NW plugin. Now, before I do that with NWJS, I have to change our configuration around a little bit. Our main has to be app.html just because that's the way that NWJS likes it, and it wants our package.json to include information about how big the default window should be. So I'm going to add that to the package.json as well. But and then there's one final thing I need to add. It's because NWJS runs the application on the file system. We can't use push state routing. So there's this Steel platform module that you can import that lets you know if you're on NWJS or Cordova. And if we are on Cordova or NWJS, I don't want to use push state. I want to use hash change based routing. So I'm going to set the default binding of can route to hash change instead of push state in these environments. And with that, I need to, so I've set up my build script, set up so it's going to use hash change instead of push state. I'm going to install the Steel NW extension, and then just run node build NW. And NWJS will actually install itself when you run it the first time, which is kind of cool. Part of itself, at least. And with that, it generated a OS X 64 and 32-bit version. I'll CD into those folders and run the .app file. And you can also build this to Windows. So it works in Windows, just like you could build Cordova to Aptana, but here I've opened up the desktop application, and I will make the desktop app talk with the browser. And I'll also show that you can have the browser talk to the desktop app. And then, of course, I have to show all three working at the same time because it's just so flippin' cool. So I'll have iOS send a message back to the desktop and the browser. Awesome. So that wraps it up. There's a lot more that DoneJS does, but I wanted to highlight its biggest features. DoneJS, I think, is really designed to solve those big challenges. I mean, I was talking with someone and they said it's the holy grail of JavaScript applications, right? It's an application that's server-side rendered, so it works great for SEO and the user experience is really nice because they see their content right away. It runs on every platform, and it's real-time. We've solved a lot of the biggest challenges really elegantly, I think, and we've done it in a way that keeps maintainability very high and is done easily. So if you want more information, go to DoneJS.com. The GitHub repo, if you find bugs and start using it, is DoneJS. We have a Chicago-based meetup that has 5 people. Once there's 5 more people who sign up, I'm going to do a free one-day, mostly free one-day training. It's $5, but that's only to make sure people are actually committed to coming, and I will bring more than $5 of swag per person. You can follow us at DoneJS, and DoneJS is usable. All of these parts are separate projects in themselves, and DoneJS is really like the nice glue that puts them together. But the sub-projects are CanJS for the MVC parts, or MVVM parts, SteelJS for build tools and live reload and dependency management, DocumentJS, which I'm not showing, for documentation, FuncUnit for testing, jQuery++ for jQuery extensions. So with that, I finished this exactly at 4:59, 1 minute early. Are there any questions? Let's check the questions at. I don't think so. Any comments? If not, thank you, everybody. And I'm going to stop the broadcast.